here's the next question for the problem of the day, that is lowest common ancestor of deepest leaf. Okay, so this is basically direct tree problem. Okay, what we have to do, like if I take the example, this is the example. Okay, this is the tree. Okay, so if I, let's just make it big so you will understand by that. Okay, so okay, so this is the tree. Okay, this will be given. Okay, as a like this tree will be given, and we have to return the lowest common, basically common ancestor. Okay, ancestor in tree is like so these are the children. Okay, so their parent node, this is the ancestor. Okay, so lowest common ancestor. Okay, so this basically leaf node has ancestor this also. Okay, that is grandparent ancestor. Okay, but we have to return lowest common ancestor. Okay, so but one more thing that return is deepest leaves. Okay, so deepest, so if you see the depth, so for this leaf node, okay, the depth is 2, that is 1 and 2, and for this also the depth is 2, and for this also depth is 2, and for this and this the depth is 3. Okay, so for both the depth is 3, so that's why it is the deepest basically nodes. Okay, so we have to return their ancestor. Okay, so their ancestor is 2, so we have to return 2. So okay, so this is the question. What we have to do, we have to first find the depth okay, deepest basically node, and then we have to return their ancestor. Okay, so what we are going to do, we are going to create a function. Okay, that is basically a DFS function. Okay, we are going to use the DFS approach. Okay, then we are going to take the things in pair. Okay, so we will the DFS function will return in the pair. Okay, how will it return that? Let's, if I write the function, it will like create the it will take in pair. Okay, so pair will contain, if I write a pair, will simply contain a tree node. Okay, tree node, that is simply okay, and one more thing is integer. Okay, so we will call this function DFS, and first it is initialized with basically the first thing that will go inside or you can say the parameters it will take is root. Okay, so simply this is the function we will create. What are the two things that contain in pair? First, this is the node. Okay, that is the simply this node root, or the nodes that we will work on, and this int, that is simply the depth of the okay node. That's if it is on 5, then depth is 1. Okay, so it will simply carry on the depth of the each node. Okay, so this will be the recursive function simply because in tree you know that recursive function always works. So simply what we'll do, so simply first, what is the base case of this? Okay, so base case, simply if we are on the leaf node, we just have to return null. Okay, so simply that's the base case. So simply what we will write, so if I just write the base case, so it would be like if not root. Okay, that is basically root equals to null, then we will simply return this that is simply null pointer. That is, we have to return in pair, you know, this two things. Okay, so because this function will return pair. Okay, so simply we will here return null pointer first node, then the depth, that is 0. Okay, so simply it will return, then we will simply close this. So this is the base case of this function. Okay, for this recursive function, because you know that. Okay, so basically let's move before moving on the approach, I will just explain you how we are going to work. Okay, so what we are going to do, we are going to on like on this route. Okay, we have gone, so we are going to check for every left node for and every right node how many depth is there. Okay, then we will compare their both depth. Okay, so if like just assume left node left basically depth is greater, then simply we will plus 1 to the depth, okay, and if right is greater, then we will plus 1 to the right, basically. And whenever the depth, that is basically right and left, is equal, okay, right and left is equal, then you will get basically, like if you see here, from here this is the okay, and from here this is okay. So if you see that from here the depth is 1, so from here the depth is 1, so these are equal. So simply we can say that we have found the lowest common ancestor, okay. So whenever the depth will be equal, then we will find the lowest common ancestor, okay. So after this base case, we will simply this you can say move to the left node, okay. DFS left, no left, basically root left, okay. We will move on the left, okay. Then what we will do, we will move on the right part, okay. Let's just write DFS root right, okay. So let's just store in this variable, that is enter left, and then second thing is in right, okay. So simply we will store not int, because this will not exactly enter, we will simply write auto, okay. That will simply get it, okay. So here also auto right, okay. So simply we will store these in left and right, okay. So after this what we will do, we will compare their depth, okay. So if left dot second, that is second is depth, okay. So here the in pair there is two things, there is first is the basically node, and the second is depth, okay. So if left dot second, that is if the depth of the left is greater than right depth, okay, then simply we will update the, or you can say return the left dot first, okay. Simply the node with increasing the depth, okay, left dot second plus 1, okay. So simply we will update the this, okay. Then simply we will close this. Then same thing we will do for right also, okay, because if just think of it, right is greater, then simply we can say we will do this for right also, okay. So simply let's just write for the right, okay. So if right second is greater than basically left, okay. So that's also like, then we will write here also the okay, and here also we will add right, okay. So basically you understand, okay. So let's just move it, okay. So this is the code, okay. Then if just think of it like both are equal, okay. So if both are equal, not right is greater, not left is greater, then we will simply return the answer, because if both are equal, then you know that this is the parent node, okay. You know that if both are equal, that is one both depth is equal, then we know that this is the LCM, that is lowest common ancestor, okay. Then we will return the root and left dot second plus 1, okay. Basically we will increase the depth, okay. So this is the code that simply, okay, we will close this. So this is the code that we will form, okay, that will simply get the answer, okay. So basically you understand what we're doing, okay. You can basically I will tell you the code in Leetcode also, and we will run it, okay. So that's the code, okay. So you can see the code in the Leetcode. You've just first initialize the DFS function, okay. First we are checking the the base case, okay. Then we are calculating the left, right, okay. Then we are checking which is greater. So simply we will return. Okay. Then at last in this main function we have written the dfs root dot first because we have to return the node. Okay, you can submit it. So yeah, you can submit it. The time complexity is bigger of n because it depends on the number of nodes. Okay. Okay, and the space complexity is also bigger of n. Okay, so that's